Hello, hi, this is from Vijayakumar, Department of Physics, SNS College of Engineering. Today we discuss the crystal physics introduction and single crystal, polycrystal and amorphous material. Then we discussed about the single crystal properties of unit cell and different types of crystal system. A crystal system is a solid material whose constitute as an atom, molecules or ions are arranged in a highly ordered microscopic structure, because all the atom to be composed to form in the clear nature in a perfect manner in an exact direction, that is called as a crystal or crystalline in a solid. Then the different types of solid we form into based on different nature. One is an ionic crystal, then metallic crystal, molecular crystal, then covalent crystals. So this four category we have based on to classify the crystals system. Then the types, the next one, the system, it's based on 7 groups. One is triclinic, monoclinic, orthorhombic, tetragonal, trigonal, hexagonal and cubic. We have formed in the 7 types of crystal system to form in very simple manner to the form of the clinic is in a 2, then the gonals is 3, then the orthorhombic and the basic system of cubic. So we discussed in all the types of crystal property to form of cubical nature. Then we discussed in the crystalline and polycrystalline to the form of difference in a crystal formations. So the crystalline, all the atom or molecule to arranged in a lattice plane in a periodic manner. But the polycrystalline is formed in the atom in some of its change from the directions. But the amorphous, all the atom it will be act in the random direction, so it's not a unique formation. So it's an irregular mode of crystalline formation. So the crystalline and amorphous is becomes an entirely different nature of atoms. Then we form in the next slide to discuss about the difference between crystalline and non-crystalline solid. So we discussed in this two, it's based on some characteristics. One is atomic arrangement, then fracture mechanism, then tensile strength, then last one is dislocation defects. So the crystalline and non-crystalline, the first one crystalline is it's formed in regular and ordered manner. The non-crystalline is in an irregular manner. Then the fracture mechanism is the crystalline is in a ductile material, so we have bended in all the formation to apply it in small stress. But the non-crystalline is become formed in the brittle nature. The tensile strength is becomes in a high, and the non-crystalline is becomes in a low. That's why it's formed as brittle nature. The next one, dislocation defect is formed possible in crystalline and non-possible to the form of non-crystalline. The next slide to form in some simple flow chart of the solid to conversion in 2 types of crystalline formation. So one is in a crystalline and another one is in a non-crystalline. The crystalline is classified in 2. One is single crystalline and polycrystalline. Non-crystalline is a form of amorphous. Right? So the single crystal, it's an example I given from that below of that title. The rock salt, then calcite, then quartz, polycrystalline, rock, sand, metal, salt. But in amorphous, it's becomes most of it's an insulating material to like that glass, plastic, resin, pitch, sugar, candy, like that. Then single crystal and polycrystalline material. So the single crystal, the whole piece, that means the entire crystal it's becomes the same nature and orientation of atom, but polycrystalline it becomes changed from that, right? Then the grains of the crystal it's becomes look like in the 0.5 to 50 micrometer. The grain boundaries it's becomes an internal surface of finite thickness. So this two is we discussed some assignment questions. One is what are crystal name, then what are common crystals, right? Because we discussed in the most of crystal we have used in this day-to-day life and real-time application. Then this 14 different types of structures to the forming based on the unit cell, right? So the unit cell is in a fundamental formation of the crystal structure. Then the atom arrangement of the unit cell is in a 4 types. One is in a corner atom, base atom, phase atom, then the body center atom. So based on this types of different atom, it's occupied in that different position in a crystal. We have discussed in 7 types of crystal system. That 7 types of crystal system we discussed in 14 different types of unit cells. So that we call this in a Bravis lattice. So this Bravis lattice we have discussed in another one topic. I hope you have better to be identify what is crystal and introduction of crystal, then some properties of crystals, right? Then other topic we discussed in other hour, right? Thank you very much. Thank you.